recipe adapter. Sam is one of our data science students. He has received his PhD in physics from Stanford University and has worked to understand the impacts of quantum mechanics on the properties of materials. Take it away, Sam.
Thank you. So, you just had dinner at a friend's house, and he made this lamb stew that was incredible. The spices were so fragrant, and it was warming and hearty, and you just had to make it for yourself. And your friend was happy to share the recipe. Now, you're all excited, but your partner is vegan, so making a lamb stew at home isn't exactly in the cards. Still, there should be a way to find a recipe featuring those wonderful flavors that meets the dietary needs of yourself, your partner, whoever shares your table. And that's where Recipe Adapter comes in. The idea is very simple. The user goes to the website, inputs a recipe URL, inputs the recipe category, and selects their dietary restrictions, and then hits search to find similar recipes that meet their dietary needs. In this case, the top hit is a chickpea and spinach stew that looks like just the ticket. It has many ingredients in common with the original recipe, including distinctive spices like cumin and cayenne pepper. Here's how this works under the hood. First, we scrape the website from the user input for a list of ingredients. Then we use natural language processing to standardize that ingredient list by extracting just the ingredient names and not the quantities or instructions. And then we need to be careful because not all ingredients are created equal. When we're searching for substitute recipes, an uncommon ingredient like cumin should matter more than a common one like salt. We account for this using a tool called Term Frequency Inverse Document Frequency, or TF-IDF, which assigns a numerical weight to each ingredient according to its rarity. We show that here schematically by font size. Then we search our database, which is drawn from the Edamame API, for recipes satisfying the given dietary constraints. For each such recipe, we compute a similarity score to evaluate how close it is to the original recipe. We compute this by simply adding up the weights of all of the ingredients that the recipes have in common. With similarity scores in hand, we simply find the recipes of highest similarity and present them to the user. So, you and your partner won't be enjoying your friend's lamb stew exactly, but with the help of Recipe Adapter, you can enjoy a vegan cousin that'll knock your socks off. Thanks so much.
Thank you so much. Does anybody have any questions? And if so, just go ahead and unmute yourself and ask those questions.
Hi, this is Cliff from Oxus. Thanks very much for that presentation. Very interesting. Could you give us some idea as far as how you landed on using the technique you did, the term frequency inverse document frequency, to basically help, weight the various ingredients?
Yeah, thanks for that question. And you did hit upon a major sort of search stage or major point of pain in this project. Took some time. So initially I thought, okay, well, I just measure the distance in terms of the number of alterations to the ingredients I needed to make, right? Just giving an integer number for that. And then I realized this problem with the rarity of ingredients, and then I floundered for a while. I tried to pick different ways of evaluating the importance of ingredients. And basically it was trial and error until I frankly learned about TF-IDF through the natural language processing unit in TDI, which was a great help. The other thing I did, which I didn't tell you about, is that I parsed the titles of the recipes also. So in the case where there's a common ingredient that might be important to the recipe, like you have a potato soup, but potatoes are everywhere, so you would miss that if you only looked at the recipe and only accounted for using TF-IDF in that case. So I gave additional weight by parsing the titles and incorporating that into the weights, giving them like an extra boost in the weights from which I computed the similarity score. So it was a lot of trial and error, but TF-IDF actually made a huge difference in the quality of the results. I hope that answers the question.
Yes, it did. Thank you very much.
Hey, Sam. Carl from Peregrine Advisors here. You
Hi, Carl.
mentioned that when you're doing your filtering, you remove all of the quantities of the ingredients. Have you considered instead maybe looking at the proportion of those ingredients to the overall size of the expected dish output and using that to help weight the ingredients even further? Because you can think of situations where there might be jalapenos in multiple recipes, but some might be very limited spice and others might be very heavy on the spice with a heavy presence of the jalapenos. That could create some difficulties in kind of the associative weightings compared to what somebody is actually looking for.
Yeah, so whether something is an accent or a main ingredient, that's a very good point. That's something, yeah, so far not incorporated into the model. Yeah, I think it would be well worth doing. One advantage of selecting the recipe categories, however, is that within a category, say soups and stews, you're likely to get similar proportions of the different ingredients. Like you won't indeed have a ton of jalapenos in a soup. It'll be, depending on the spice level, it'll be roughly similar. That said, that would be a valuable thing to incorporate, and it would present some exciting challenges in terms of standardizing units. You would have to extract those. You would have to do some more sophisticated parsing, and you would have to do some ingredient conversion between, volumes and masses and metric and English. But I totally agree that that would be an avenue towards making this this tool more powerful.
Thank you, Sam. If there's time for one other quick question, just if you had 30 seconds to describe how you think you might try to tackle that.
Let's see. Yeah, so, I mean, I think, frankly, there's going to have to be some stuff hard-coded in. So there's a relatively limited universe of measures that are made that are used in foods. You're not going to have to deal with micrograms or millibarns or whatever the funny units are. So parsing to get the quantities and units, I think, should not present too much of a challenge. And then, yeah, I think you would just want to, I guess, evaluate the total quantity of ingredients in the recipe, and then do proportions. So you would have an additional, say, add additional features to this this vector, accounting for the different, that weights the proportion of those ingredients in the recipe. I'm not, more than that, I'm not going to be able to say something intelligent right now.
That's completely fine. I only asked for 30 seconds, and I think you gave me a little bit more than that. So that's
Oh,
great.
I'm
Thank
sorry.
you so much, Sam.
Thank you. Thank you for your question.
Thanks everyone so much for your questions. We are going to move on to our second presenter. So our second presenter is Jason Dahl, and his capstone project is entitled Predicting Cadet Success in Physics 1. Jason is one of our data science students. He earned his PhD from Brown University in Earth, Environmental, and Planetary Sciences, and he is currently a lecturer in physics at the United States Coast Guard Academy. A lot of words there. Take it away, Jason.
Can everybody hear me?
Yeah, I got you.
We can.
All right. So thank you, Lauren. And as you just heard, I teach physics at the United States Coast Guard Academy. And while the Academy recruits high-achieving students from across the nation and around the globe, every year we have cadets that struggle to pass Physics 1. And this is a problem because it can delay their graduation, which delays their transition into the operational Coast Guard, costing us all time and resources. But it can also result in disenrollment if things are bad enough. And that can cost the cadet themselves basically $250,000 education and the loss of their career. And so while we have academic support programs in place, a lot of the times we don't recognize that a student is struggling until they've failed an exam or two, and then they're already behind. And so to address this, I've built a tool that looks at some institutional data that we have right at the beginning of the semester and uses it to train a machine learning model that we can use to predict who is likely to struggle in Physics 1, even before they've done anything in the class. And then we can get a report on those cadets that even includes why they might struggle. And so the types of data that we're looking for these students are things like their math placement score at the academy, their academy and their high school GPAs, their standardized test scores, how well they did in calculus if they've taken it. And we can use these to predict either whether they're likely to succeed in Physics 1, get a C or better, or whether they're likely at risk, a C- or worse. We have about 6 years of data that we're using to make this prediction. And over these 6 years, we've had over 1,500 students that did just fine. Most students do just fine when they take Physics 1. But we have about 100 that didn't do just fine. They got a C- or worse. And these are the ones we want to focus on. After we clean and transform our data, we just saw that we have a lot more successes than not successes. And so we do a little bit of oversampling, synthetic oversampling to address that, to get our classes more balanced out. And then we train our model. And as you can see here, the results of the prediction that our model makes on a test set that we held out for testing purposes, that we have about 15 students that we recognize or that we predict to be at risk that actually did badly. We have quite a few more that we predicted might be at risk that actually did well. And this is fine. Most students who might be at risk study hard, do well. History isn't destiny. And so what we really want to focus on are these few that we predicted to do poorly and did. And so we can't just throw everybody into an academic support program. We want to hone in on those a little more closely. So one way we can do that is to take a look at how confident our model is, and as a function of confidence, how good our predictions are. And we see that for kind of lower confidence predictions, our accuracy is really low. But if we get over to 90% or better probability of being at risk, our model accuracy jumps way up. And so we want to focus on these people who are most at risk early in the semester. And so we can take a look at this, maybe set a threshold, and we want to focus in right at the beginning of the semester on the people that are we're 96% confident, for example, might struggle. And if we set this threshold for this particular training group, we say there are maybe 6 people that we want to flag right away. And so we can use a tool then called Lime to generate an at-risk report for these. And this is what that looks like. For example, cadet number 122 for this random identifier, our model said is 96% likely to struggle in this course. And if we look at why, the model shows them to be at risk probably because they failed Calculus 2 before or got a D and have to repeat it. And so based on that, we might want to get them into some math support right away. On the other hand, cadet number 207 not only did poorly in Calculus 1 when they took it, but also seems to be struggling overall. They've got a GPA of 2.3 or so. And so in addition to getting them into some math support, we might want to focus more on study skills and in Physics 1 in particular, we might want to get them into some of our mandatory practice sessions. With the hope that if we can get them through Physics 1, they can find their footing and transition into the fleet where they can serve their country. All right, I'd be happy to field any questions. Thank you for your attention.
Thank you so much, Jason. If anybody has any questions, again, feel free to unmute yourself and ask those questions.
Hi, Jason. This is Cliff from Moxis. Thanks for this, and actually, thanks for this project. It's nice to know our tax dollars are going to be used more effectively, and that students are going to go through the academy a little bit easier through this. I am curious though. I get the algorithm and essentially all the different factors it uses to create the at-risk calculation. What I'm curious about is how did you go from making the prediction of as you gave the two examples, how you went from their risk calculation to recommended actions, how you basically made that transition?
All right, so I mentioned that we generate an at-risk report. I use a tool called LIME, which stands for Locally Interpretable Model Agnostic Explanations, that takes a look at kind of where they are located based on those 15 or 16 things in kind of our model space. And then it perturbs those predictions a little bit to see which ones are most significant, which contributed most to landing them in their in that category. And so when I have the model, have Lime do an explainer, it puts out both their at-risk probability and also we can see a little graphic over here that kind of ranks where things are in terms of their significance. And so this particular cadet, we have some high predictors of likely successful. It's their first time taking Physics 1. If they take it more than once, they tend to be more at risk to fail it a second time, unfortunately. And their math placement didn't automatically put them more at risk. But then we see that, when they have taken Calc 1 before and they didn't do as well in it. And so that in the opinion of Lime is the most significant reasons why they might be predicted to do poorly again, because they're having some struggles in calculus. Does that answer your question?
Not quite. So you said that the Lime does an explainer, which gives you, the reason why they failed. But again, what I was just trying to say, how did the connection be made to the corrective actions, to the, what exactly, did you use to go from this is what happened with Calc 1, but this is what we're going to do for an action?
Oh, well, part of that is, I think, what we call domain knowledge. Having taught a lot of students in this particular course, we know that people that struggle to understand basic calculus concepts struggle to learn basic physics concepts because, the language of physics is written in calculus. And so I'm, using a little bit of teacher wisdom there to say that, this calc is probably why they might struggle in there. And I see that as significant.
Okay, and similar to when the student that had a lower GPA, that linking that to potential study habits and also getting them into a rigorous, like you have to go through some of these
right
courses. Okay.
We have a program called Forecast, fourth class academic assistance program, and or academic support program that, if they fail a couple of exams and their exam average gets too low, we can actually mandate that they go to these sessions.
Okay.
But we often don't see that, once we've gone if they failed 2 exams already, the horse has already kind of left the barn in that case. And so we want to get some of these cadets in there earlier.
And finally, as far as identifying Lime as really kind of the main driver engine of the algorithm. Just wondering how you came across that, and is it like in a standard GitHub library or various different versions of Lime? Just kind of curious on Lime itself.
Yeah, and so I happened to read a couple of papers about this, and there was a paper that tried to do something similar based on like some Coursera data, and they used Lime to support this. And when I originally started doing this, I know when I'm using a logistic regressor, I could probably, just look at some of the weights and not worry about that. But I was originally trying to do this with a random forest classifier, and those are a lot more black boxy. And so, in addition to making some fairly nice graphical output, Lime can handle those and unblack box some of those more powerful tools if we decided we wanted to go in that direction.
Thanks very much.
Thank you.
Is there time for one more question?
Sure.
So let's say that you implement this system and it's successful. You successfully intervene with the candidates that are at risk and they stop failing Physics 1. How do you adjust your model for that? Because at that point, your model will see that there are candidates that are being selected for intervention, which then won't be failing the class, so it won't know who actually needed that intervention to begin with.
So one thing we would need to do with that is probably start keeping a bit more rigorous records about who is in these programs and when. We have some of that going back a little bit, but it's a little bit spottier, so I didn't include it. But basically, in that case, if we are going to, if people get into there and doing well, I mean, that's a success. And so we could probably engineer a feature that takes that into account. Spent so many weeks in forecast, for example, and then that would be one more thing to classify.
Okay, but do you think that you could have any situation where you might end up in that case capturing too many people because of kind of the limitations of knowing who actually should be in the program or who shouldn't be in the program?
I mean, that might, include those numbers or adjust those numbers. We get a lot of people who are flagged as at risk at the beginning that we that actually ended up doing just fine. It might inflate those numbers a little bit. And so, one of the reasons for doing that kind of that probability thresholding was to limit those in the first place. But yeah, I think that would be a thing we would have to keep an eye on. I'm not quite sure how we would do that right off the bat.
No, it's not an easy question to tackle at all, but thank you for your response.
Thank you.
All right. Thank you so much, Jason. I see that we've had a few people come in a little bit late. If you are a hiring partner, go ahead and your Zoom name, have it your name and then your company. So at the end, when we do our networking, it will help us separate our partners out. And TDI students, make sure your name says your name and then TDI student, so we can make sure we get you in the right place as well. But our third presenter is Hung Lin King. Hung will be presenting her project, Foodie With. Hung is in the data science cohort, and she has a PhD in neuroscience from the University of California, San Francisco. Take it away.
Hi, thank you so much. Can everyone see my screen right now? Awesome, thank you. So in my family, we love going out to get good food together, but my sister is vegetarian and I have a gluten allergy. So finding a delicious restaurant that can accommodate our dietary restrictions is often a long and involved process. This problem is also not specific to my family. 40% of Americans have a dietary restriction due to preference, religious, or health conditions. So Foodie With streamlines this process by providing one centralized website where you could go and enter in your party's dietary restrictions and get a list of restaurants that can accommodate everyone. So here, I can enter in vegetarian for my sister, gluten-free for me, and a zip code in Philadelphia where my sister lives, and I'm looking for restaurants that's open for dinner tonight. So Foodie With then gives me a map of restaurants that's currently ranked by most reviewed, but I could also have selected the best restaurants for each dietary restriction, as well as the closest distance. So how does Foodie With come up with these rankings? So what is going on in the background is Foodie With is taking in Yelp reviews and filtering by nearby and open restaurants with good food, since this website is for people who appreciate good food. And good food is defined as restaurants with a minimum of a 4-star rating, as well as restaurants that's good for your dietary restriction. So how does Foodie With decide if a restaurant is good for your dietary restriction? So what happens is Foodie With is going through these Yelp reviews and pulling out Yelp reviews mentioning keywords such as celiac and gluten-free, which identifies reviews for gluten-free diners. And from these reviews, it's pulling out the star ratings of the individual reviews and taking an average of the star ratings. So Foodie With also shares the most recent review as well as the most useful review for each dietary restriction. So let's take a look at it in action. So from this map, it's useful, and I could see that the top #1 restaurant here is the Reading Terminal Market, but I'm curious to learn more about my other options. So I could click top 10, and I could see that this is a food court. And I could, the next one is a Mexican restaurant, and then there's also a Middle Eastern restaurant. And I could also expand down to learn more, so I could see the location and hours, which would help me get there on time, as well as the average rating and the average rating for each dietary restriction, and also the rating distribution for each dietary restriction graph. So I could see that it's a good fit for both vegetarian and gluten-free diners with a lot of 5-star ratings and no 1-star rating. So scrolling down, there's the most recent and useful reviews for each dietary restriction. And with the review of the most magical place on earth, how can I not check this out the next time I'm in Philadelphia? Thus, Foodie With provides us an answer to an age-old question, what's for dinner? Thank you.
Thank you so much. Does anybody have any questions?
Hi, Yuan Huang. How do
Hi.
you deal with situations where you have, potentially a large number of reviews for the restaurant, but only a handful, 1 or 2 reviews that actually meet your specific dietary restrictions, especially when the star ratings on those reviews diverge pretty significantly?
Yes, so I have a filter for exactly that type of situation. So if there's only 5 reviews, so I went through and looked at a lot of restaurants and the reviews that are coming out. So if there's less than 5 reviews and 1 review is less than 5 stars, I cut the restaurant from the list. Because usually when there's that small of a number of reviews, the one review that's kind of the dissent has a lot to say, and it's usually pretty impactful. So I weigh that a lot.
Okay.
Does that answer your question?
Yes. I did want to make a, not necessarily a recommendation, but point out a technique that could help with those kinds of things, Bayesian mean regression. So if you have a situation, have you looked into using that for?
I have, but I haven't implemented it yet.
Do you think that would be useful in your situation, or do you feel like because those lower or dissenting reviews tend to be pretty impactful, that Bayesian mean regression would actually be problematic for?
I haven't thought about that. I think that might be good for kind of a middling number. So in the case of like a gluten allergy, there's a range of people who are gluten-free, like people who are gluten-free for more like a preference versus celiacs who have an allergic reaction. So I feel like that might be good for kind of categorizing restaurants on that spectrum a bit better. Does that make sense?
Yeah, I think so. Basically, based on the severity of the condition, how much flexibility do you have in accounting for
Yes.
that regression towards the mean?
Yes, because I know like even with some religious dietary restrictions, some people like really care, and others are like, oh, this is okay. So I think if I kind of have a filter for like how much this matters, that might be helpful for me to sort by.
All right, thank you.
Yeah, but that's a good suggestion. Thank you.
Hi, this is Cliff from Oxys. So just
Hi.
I'm struggling just a little bit to understand, what was the basis of the algorithm to from the standpoint of the ranking method, both from the standpoint of how did you rank it based on, again, what appears like some of the NLP features, of the overlap, gluten-free, vegetarian, but then also to determine what were the highest. I get the higher ratings of the restaurant, but was it more of a straight regression type based algorithm? Could you give us a little more, give me a little more understanding of that?
It's actually really simple because I realized that oh, let me scroll down. So usually gluten-free diners who had a good experience in this example here give restaurants a really high star rating. So I did not even use neural language processing or anything fancy. So it's really just filtering through reviews, pulling out reviews that's mentioning words that's associated with, in this example, gluten allergy, and taking an average. And for the sorting method, this is just the most number of total reviews. This is most reviews regardless of the dietary restriction. And these are the most number of reviews for each dietary restriction, because this is already pre-sorted so that the restaurants that are pulled out already have a minimum of 4-star rating for like good overall food and good fit for each dietary restriction. So it's very simple. It's just filtering right now. Does that make sense, or does that help?
Yes, thank you.
Yeah.
Thank you so much. We are going to move to our next presenter. It is Claire Healy-Levitt, and her project is called Identifying Monarch Life Stages with Computer-Assisted Vision. Claire is one of our data science students. She received her PhD from Harvard University in Earth and Planetary Sciences and has worked in industry as an R&D engineer. Take it away, Claire.
All right, thank you, Lauren. I assume everybody can hear and see me. Let's see, so you guys are all probably familiar with monarch butterflies, but you may not be aware that these guys are in some serious trouble. So monarch butterfly populations are monitored by counting overwintering butterflies in special locations in California and Mexico. And over the past several decades, these populations have crashed. There is legitimate concern that without significant intervention, the monarch butterfly could go extinct. There are a myriad of reasons why this population crash has happened, but scientists speculate that most of the problems are happening in the migratory breeding grounds. So that includes increased pesticide use and overall habitat loss. So to develop a conservation strategy, it would be really helpful to know when and where monarchs are trying to breed. So tools like iNaturalist can provide a basis for such an approach. So iNaturalist is a citizen science app that uses machine learning to identify plants and animals. It has a global user base, and at present there's over 200,000 monarch observations logged with the app. Although monarchs, the app is capable of identifying monarchs in its various life stages, because life stage was not part of the original data model. The app actually relies on user input for determining life stage, and it's not a model output. So as a result, most observations don't actually have life stage metadata associated with them. So To extract life stage information from the iNaturalist observations, I have developed a convolutional neural network model to get that information. To train this model, I collected around 5,000 observations from the iNaturalist database, and I hand categorized them as adult, egg, larva, or pupa. And then I trained a model. So I took a transfer learning approach and used a pre-trained model known as Inception v3. Inception v3 is a convolutional neural network that has been pre-trained with the Google ImageNet database, and as a result has learned something about how to parse images. So I took that model and I further trained it with my butterfly life stage classification data set. And with this approach, I was able to achieve a 97% validation accuracy. I have then gone on to apply this model to all 32,000 observations from 2019. And with this, you begin to answer these questions that we need to develop a conservation approach, which is when are monarchs breeding and where are they breeding? So just focusing on my neighborhood in northern New England, I have plotted a temporal distribution of observations binned by life stage and week. And then I have also created a heat map of larval spatial distribution. And the hope is that, with this approach, we can develop a data-informed conservation strategy that will help keep the monarch butterfly around for a long time to come. So thank you for your attention, and I'm happy to answer any questions you may have.
Thank you so much, Claire. Does anybody have any questions for her?
Hi, Claire.
Hi.
Thank you so much for presenting this. I wanted to be an entomologist when I was young, so it's definitely exciting. Well, not exciting to see what's happening to monarchs, but the project is exciting.
Thank you.
Do you have any concerns about the data distribution that you're actually going to see through iNaturalist? Does the heat map that you're putting together actually map what be expected for the distribution, or do you see areas where there's definitely not as much coverage as you'd expect from?
So wonderful question. And I have to say that this is a biased data set, right? So essentially, we're only getting observations from where people have this app and have the inclination to use it to identify butterflies. There's also a skew towards observing adult butterflies more so than, egg or larva or pupa. I would argue, though, however, that even this skewed data set it still provides some value. So for one, probably the regions with the biggest risk are where, human and monarch habitat overlap. So this app will provide data in those regions. And then, really we have to compare this to the alternative, which is essentially no data. So does that address your question?
I don't mean to say that the data isn't useful or important, because the next question really is, even understanding that the data is biased, what do you do with that data to actually affect the change that you need? I think your point that even if the data is biased, it is showing where those major threats are between human species interaction are useful, but then how do you actually adapt that?
So I think I would need to talk to an actual conservationist about what approaches they would use. But just thinking of temporal distribution, usually, especially in the region I'm in, the monarch butterfly is occurring at a time when farmers might be using lots of pesticides. So figuring out if there's can we recruit farmers to either use shorter-lived pesticides in those time ranges, or even advocate to avoid using them at all. And then looking at the actual distribution, like the spatial distribution, we can start to compare like the spatial distribution of observations to land use and decide if are we seeing larger observations in developed areas, and should we put our resources towards developing community gardens, or are we seeing them in mostly agricultural areas where we might want to, again, get farmers involved?
tons more questions I'd love to ask, but I'll leave that for now.
Okay.
Thank you so much.
Thank you so
Time
much.
for one more question.
Sure.
Sure, go ahead.
So first of all, again, yes, I agree with everything that Carl was saying about what a great project, because it's an important issue. But could you talk to us a little bit more about, I'm curious about, obviously an image processing problem. You chose convolutional neural network, and then kind of landed on this version of a transfer learning, this particular one. Can you kind of walk us through what led you to choose that, this particular route for the algorithm?
Yeah, so I will admit that we haven't even gotten to the TensorFlow portion of our of our class yet, but I was really gung-ho to do image processing data set and project. So it was a learning process for me to even learn what algorithms were available. So, essentially with the guidance of my instructors, they said, this sounds like a deep learning problem. So that's what led me to a convolutional neural network. And I was actually able to get with just like a very simple I think 3-layer convolutional network neural network. And then I learned that it's actually these pre-trained models are pretty dynamite. So I decided to just give one a try and was able to get some success out of it. So a little bit of trial and error, a little bit of learning in the process. There's probably additional models that could be tried, or additional approaches, but this is just the one I landed on for now.
Congratulations. It seems like it's pretty effective. So thank you.
Thank you.
Thank you so much, Claire. So we are going to move on to our final presenter, Mark McLeod, and his project is called Brewery Finder. Mark is one of our data science students. He received his MS in mechanical engineering from North Carolina State University. And prior to TDI, Mark worked in the consulting industry as an early stage product designer. Take it away, Mark.
All right. Can you see my screen? Great. So thanks for the introduction, Lauren. Hello, everyone. Today, I'd like to talk to you about something that many of us enjoy, and that is breweries. So imagine you're a typical brewery goer looking for a new place to try. So you're visiting a new area, and typically you might use a tool like Google Maps. And Google Maps is great for finding and visualizing all the nearby breweries, but unfortunately, it does not easily provide the offering information that might be important in your decision process. So for example, say I'm looking for something with outdoor seating, serves food, allows dogs, etc. I might then click through these individual listings, look at the pictures, read some of the reviews to start to gain a sense of what is actually offered here. As an alternative solution to streamline this process, I created Brewery Finder. So in this one central interface, you can enter in your address, see all the nearby breweries, and then filter based on the exact offerings that you're looking for, thus saving a lot of time and effort in your decision process. So for example, say I'm visiting Boston, Massachusetts, and I'm looking for something with outdoor seating, serves food, and has games available. I can quickly see the remaining options that meet all my criteria in blue, as well as the options that don't meet my criteria, but if location is important to me, these are still shown in gray. As I hover over the options, I can see the different brewery names, see if I might recognize one of them. If it looks suitable, I can click on it and get a nice summary of all the feature information. Oh, looks like Streamlit just reset, but this is live, so sometimes that happens. But so say, then you, so you click on an icon and then you get all that feature information. And then as well as that, you get the address. And then if I want even more information, I can then click on the name, which will bring me directly to the website. So under the hood, what Brewery Finder is doing is it's built on a web scraped data set from TripAdvisor brewery reviews. And on this data set, I've currently scraped over 16,000 reviews for over 600 breweries across 7 states in the Northeast. And on this review text, a natural language processing model is run that uses a pattern matching rule-based approach. So it's looking for keywords and phrases that indicate whether or not a brewery has a specific offering. So you can see in this image here, this is an example review text, and the model is able to match on words like patio, outdoor, and other words like outside to indicate whether or not outdoor seating is available. Similarly, it's matching on words like dog and dog friendly to indicate whether or not dogs are allowed. And lastly, the model is also able to handle special cases like the word hot dogs, where we can see here, the model is able to identify it as a food indicator rather than a dog-friendly indicator. So thanks to Brewery Finder, you can find the best brewery for you in no time. Thanks.
Thank you so much. Does anybody have any questions for Mark?
Hey, Mark, did you account for negations in your system? So if somebody says dog friendly, but the actual text is not dog friendly, does that get picked up?
Yes, so part of like that hot dog example, there's basically a set of rules that I've implemented that look for things like no dogs or not dog friendly. So those have to be hard coded in because I'm using a rule-based approach, but the model is able to pick up on those.
Okay. And if you wanted to move away from a rule-based approach, what would you think would be kind of the next step for something that's a bit more probabilistic?
Yeah, so I actually started with a more complicated statistical NLP model through Spacey. And the problem was that it required a lot of training examples, right? So I had to go through, I went through about 200 reviews, manually labeling everything, all the instances of dog or outside or patio and foods, and basically ran it through the whole Spacey pipeline and was able to compare that to the rule-based model, which I basically used as a baseline. And it turns out that, with 200 examples, they were basically performing the same in terms of precision recall. And so because, rule-based approach is simpler and more explainable, that's what's currently implemented right now. But if I wanted to get more fancy, I would have to feed that statistical model more training examples.
Okay. Yeah, I definitely don't envy the need to label a whole bunch of data.
Yeah, it's quite a process.
Right. Thank you, Mark.
Do we have any other questions for Mark?
So I'm going to get in over my head with this question, but just hearing you talk about the challenges with the labeling and it not having getting close to the precision still of the rules based. If you were to take that on, would you be looking at other approaches? Again, such as things like transfer learning, so that it reduces the burdens of things such as labeling and along those lines. What would be your way to kind of overcome the issue that you kind of bumped into?
Yeah, I think in this particular example, because the labels are very specific, like I'm just looking for words related to outside and whatnot. One approach would be just to implement a bunch of more rules that look at very similar words to outside or dogs or whatnot. On the labeling side of things, one thing that I would probably first try is just adding more examples. The process is just a little tedious, but it is somewhat streamlined in the sense that there's this other program that allows you to basically go through a review and label it and then feed it through this pipeline that basically like pulls out all that nice visualized method of labeling everything and then turn it into a text file, say, that it can read. So I'd probably approach it that way just because I'm honestly not too familiar with how to use transfer learning in this particular application.
Excellent. I'd only have one other suggestion, and that is maybe in version 2.0 to use something like more like the Untapped app that is focused on different types of breweries and as opposed to a TripAdvisor. But that's just like to have.
Yeah, it's certainly points to the fact that this data set is biased just because it's only pulling from TripAdvisor. But yeah, something 2.0 would certainly use a lot more data sources to get a better sense.
Thanks.
All right. Thank you so much. And thank you to all of our presenters for your hard work. I know how much energy it took to do those capstones, and they